All right, in 7.4 on Friday, we talked about our Theorem 7-3, which said that, again, if we have an altitude drawn to the hypotenuse, that divides our triangle into two smaller triangles, all three of which are similar to each other. So let's look at the back side of our notes then. Looking at the back side of our notes, we have two corollaries that go along with that. And if you remember back, a corollary is simply another theorem that can be easily proven using the original theorem. Okay? So corollary number 1 can be easily proven using Theorem 7.3. So what corollary 1 says is that the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of its two segments. Okay, now geometric mean, we haven't really talked about that. Let's set up the proportion. Really, that's all we need to do is set up our proportion here. Okay, and to do that, I'm going to help you because sometimes it gets confusing looking at the A's and D's and C's and D's and trying to match everything up. Okay, what they're trying to tell us here, if we have, let's call this A, this is B, and the altitude is C. Okay, those are our three lengths. Key thing to notice about this corollary is that we're dealing with the length of the altitude. Okay, the other key thing is that the length of the hypotenuse is cut into two separate lengths. All right, it's cut into two separate lengths, A and D. Okay, so they are saying that this short length, A to D, so one segment of the altitude, or the hypotenuse, corresponds to the altitude. And then the altitude corresponds to the other length. Okay? So A over C equals C over B. That's what they're having us do. Please make sure you copy that down because that is going to be a little bit more straightforward for you to figure out than the other one. Okay, so we have one segment of the hypotenuse corresponds to the altitude, and then that altitude corresponds to the other length of the hypotenuse.
How did you know?
All right, the second corollary. This one kind of gets a little confusing. As far as how you read that. So the altitude of the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg. Holy buckets, what is that saying? Well, come here. Look at this part. Again, we want to go through and talk about individual pieces, okay? So if I look at this entire hypotenuse, let's call that W, okay? We'll call that W. And then I want to look at AC, let's call that X. And I want to look at AD, we'll call that Y. Things to notice here. Things to notice. And this work, the reason they have two proportions here is because it works with the leg AC, but it also works with the leg CB. We just have to adjust it a little bit. Okay? So looking here, notice that the segment of the hypotenuse, meaning the small segment of the hypotenuse, that Y segment, A to D, that segment is adjacent or next to the leg that we know. Okay? Excuse me. X and Y are next to each other. Okay? And then we also know the whole hypotenuse. So, we have the hypotenuse corresponds to the leg in the same way that the leg corresponds to that little segment of the hypotenuse. That's what they're talking about in this proportion. the whole hypotenuse corresponding to the leg is equal to the length of the leg corresponding to that little part of the hypotenuse that is adjacent to that leg. Again, please make sure you write that down. That makes more sense in my mind than what they have written. Excuse me. And that works on the other direction as well. So again, our entire hypotenuse is W. Let's say we have, oops, and I missed a letter here. So let's go ahead and call this Z and P. Sure. Okay. So if we're working the other way, again, notice that Z is the length of that leg, and P is a shorter part of the hypotenuse, but it's adjacent to the leg that we're talking about, Z. Okay, it's next to that leg. And so our proportion here is that the entire hypotenuse corresponds to the leg in the same way that that leg corresponds to the small part of the hypotenuse. W over Z equals Z over P. So, taking a look here, let's start out with problem number 4. Number 4 is a good one here. How do I know which corollary to use? Well, looking at this, am I dealing with this altitude at all? No, I don't have a variable there. I don't know the length of it. Therefore, I am not using corollary number 1. I must be using corollary number 2. And in corollary number 2, I see that this segment I'm looking for, A, is adjacent to this leg 6. And so therefore, following my theorem, my hypotenuse corresponds to the leg in the same way that the leg corresponds to that segment of the hypotenuse. The hypotenuse corresponds to the leg in the same way that the leg corresponds to the segment, adjacent segment of the hypotenuse. In which case I can simply simplify this down. And 2a equals 6, so a must equal 3. Let's look at this one, number 5. In number 5, am I using the altitude?
Yes.
Yes. Yes, I am. So therefore, I must have to use that first corollary. And that first corollary says that the first segment of my hypotenuse corresponds to the leg in the same way that that leg corresponds to the other segment in my hypotenuse. And now I can go through and solve this. X squared equals 48. And so if you leave the answer as x equals the square root of 48, I would accept that for today only. I want you guys to be able to reduce that into 16 times 3, which is 4 square root of 3. But we can talk about that more tomorrow before we get to our test. Okay, so for today, square root of 48 is acceptable. This is preferred. Okay? All right, let's go to our homework. Make sure we have some practice on this stuff.